AI predictions 2025. So you have been eerily correct over the past 18 months. We've been working on this company on what is to come, what the rate of progression has looked like. And so we figured we'd finally put you on record and try to give you some credit for some of these predictions. So there's a consensus amongst the people in media right now that AI is sort of hitting a ceiling, that that we're going to stall out, and that would be fine. But what do you see coming up for 2025?
I want to address the perception that people have, that AI is stalling. I think when you're looking at, if you think of the perspective of the public, you're looking at the leaderboards, and you're looking at the apps, and you think, hey, not much has changed. I could do tool calling yesterday. I can now do computer use, which you can say is, glorified tool calling. The apps haven't changed as much. The models, they're getting better, but the difference is barely perceptible. So yes, it may appear like that, but it's important to focus on what's actually happening under the hood. What's happening there is that the software layer is evolving rapidly. If you look at the tools that you have today to build stuff, OpenAI has an agentic framework. Crew AI has an agentic framework. Microsoft has a couple of agentic frameworks. I'm pretty sure Google has a version of it. LangChain, LangGraph remains to be one of the popular frameworks. You have a lot more agentic frameworks. The technology is a lot more accessible. Most of the major model providers support tool calling. So what happens in the space is one model provider puts out a model, and then eventually it supports tool calling, these structured outputs, these other features that make it more accessible to developers and usable in applications. So natural effect of that is we're going to see a lot more agentic applications in 2025.
That's right.
Sam Altman mentioned the $1 billion company. That is going to be a reality. It is already a reality with multiple people right now at many companies, but it's going to be much more obvious to see that just because you can connect these LLMs to anything. As of today, after Claude, computer use came out, and a bunch of other similar solutions are in the pipeline. You can now, on your local system, ask Claude to do almost anything. They also have this, Anthropic put out this open source framework that lets anything connect to any LLM, and it's supposed to be tool agnostic, model agnostic. For example, it can connect to GitHub, it can connect to any other local app, right? And then NVIDIA has been putting out similar solutions in the beginning. So it's been in development for a while. But what you're going to see now is this agentic applications that can connect to anything. The barrier of, hey, okay, I want to connect this to my LLM, but there is no integration, is now about to be broken.
That's right,
So you can connect your LLM to anything, and LLMs are smart enough to answer and address a diverse variety of use cases. So what's essentially going to happen is more and more everyday workflows and more everyday things that humans do are now going to be AI enabled.
I think that the market has consensus that agentic AI is like the thing in 2025. So no one's going to fight with you on that. But to you, what does that actually mean?
I think what that means really is in terms of really onboarding AI and really expediting, integrating AI into multiple things. The key barrier was that the interfaces were tricky. Like, for example, if you talk about healthcare, right? It's challenging to use AI over there because data is private. It cannot leave boundaries. It cannot leave, for example, you cannot send that to the cloud, because if that gets leaked, you're violating someone's privacy, and it's mortal danger to that person whose information got leaked. And that's one specific example where if you're able to have these hyper local systems that can be encapsulated between virtual private clouds or on premises, and that have much better integration points across legacy and modern systems, where in the legacy system it's just hard to integrate LLMs just because the technology stack is so backward. But you now have these generic frameworks that can overcome that barrier. Then you can now bring AI to these so far backward use cases, and the impact of connecting AI to something like healthcare is extreme, because healthcare is in many cases hard to make generally available to everyone, to make accessible, and this is a problem that we've been struggling to solve for many years. But this is something that gets solved within 2025 for healthcare with LLMs, right? And that is one example. There are tons of other examples in other domains that get addressed because of this. And the key thing is not really the improvement of the AI itself. It's about the tool stack surrounding the AI that makes all of these things possible.
Which is just starting to mature, and mature
Yes.
might be the wrong word for it, but I hear you on the connectivity piece, right? We need to be able to connect to these systems. We're going to have the scaffolding for that.
Yes.
But talk to me about multi-agent interaction and what that means once we're connected for LLMs executing labor.
Yes, I see multi-agent as it's more of a stopgap solution to the limitation that AI agents have a limited context window.
Yeah.
And they have a limited output limit. So the AI agent and the way the transformer technology works, right, and the way these agentic systems work is it's simpler if the agent adopts a persona and you split a job into multiple tasks and maybe have multiple agents specializing on every single task. It's also great to think of things that way because that's also how humans work.
Yeah.
Humans have a limited capacity and a limited ability to specialize. You can either go broad or you can go deep, right? That's a biological limitation. And interestingly, that happens to apply to the AIs of today, which is why multi-agent architectures are a thing where you can specialize, like I said, divide, specialize, and that helps you if you're done correctly, and if the task is divisible and generalizable in that sense, then multi-agent solutions are really powerful. For example, in case of Blitzy, with a single engineer or a single model, and let that be a model as small as Claude Haiku or as big or great as the latest O1 was just launched today, the day we're recording this. You are limited in terms of the output that it can produce, and no matter how good it is at thinking, you are limited in terms of the input that it can assimilate and the level of fidelity that it has to all the information that it has assimilated. So at Blitzy, we can take 3,000 instances of O1 and apply that to extremely complicated problems, which are enterprise repositories, groups of enterprise repositories that have more than a combined millions of lines of code. And we can ingest that information, divide that, and then make meaningful updates or create meaningful products from scratch based on the knowledge that we got from all of those repos, all of those lines of code, and by assimilating all of that information in a way that it's meaningful for the enterprise. Like, for example, you're getting a product that follows your existing code guidelines and standards, that uses your existing internal services, and that follows your design language consistently. And these are all problems that enterprises use very talented humans to solve, and it takes up a lot of time for those humans. But now those humans can focus on other more challenging parts that the AI agents of today cannot solve.
And you're describing multi-agent here as a limitation of the state of the existing models, maybe insinuating that once they get much larger context windows, both much larger output windows, that multi-agent won't be needed.
Yes and no. I think in certain cases, like for example, if I had a large code base and I could send a single agent to handle all of it, I would prefer to do that.
Totally.
Just because it's easier operationally and I don't have to invent stuff like we did for us to stitch context across multiple agents, for us to ensure that the agent is always, every single independent agent is always grounded in the same information and it's not overlapping in terms of the output that is produced, and it's also not conflicting in terms of the task that it's doing with the decision criteria or with the work that was done by previous agents. There's also the concept of redundancy, where someone can invalidate someone else's work. So these are all problems that we've had to solve just to enjoy the benefits of a single model being able to do this today rather than 5 or 6 years out. But if I had a single model, I don't have to deal with all of those things. It's much simpler. I can get much more consistent outputs. I can get a lot of output, and the quantity of output would be high. And I can then simply solve these problems within my web page of chatgpt.com or whatever page that is. And it's orders of magnitude simpler. But there are still other use cases. Like, for example, if it's a very specialized use case of UI. So we learned from all of our experience, building UIs, that if you want to be really good at building high quality UI that that just pops, that follows all enterprise guidelines, There is value in post-training, also better known as fine-tuning.
Yep.
Another example is O1 in their own, OpenAI in their own study with O1. They tried O1 with a data set of some competition, and they saw the results. They scored, I think, 808. This is public on OpenAI's O1 website. And then they fine-tuned O1 with some programming data, and that was data relevant to the competition, and it was generic data about programming that would be helpful in that particular context. And the score went from 808 to 2,500 to 2.5K, right? So that's a use case where specializing on that particular task helped the model get better at programming. But I'm pretty sure if you took the same model and you gave it something else that was not programming, it would not perform as better.
Yep.
Fine-tuning or post-training would actually worsen its performance on some other tasks.
Yep.
So in those cases, it helps to have multi-agents and have some agents specialize on specific tasks and go quite deeper, just like you have humans, and you have some PhDs that are only focused on solving, for example, issues with thermodynamics.
Yep.
And then you have business managers that are doing more broad variety of tasks. I see the same happening in the agentic space.
Yeah, I mean, the effect of specialization has been a staggeringly wonderful discovery when we went to just solve the context issue, right? We discovered, well, if we have to split these things up, we may as well have some that are specialized, and you're able to dramatically increase the results by post-training, which is a great side effect for us. So I'm curious to dig in a little more. When the industry is saying agentic AI, do you think that they're talking about the same thing that you're talking about right now?
Not really.
Okay.
I think agentic AI is also often conflated. I once did a talk at HBS, and I had we did that talk at HBS, and I had someone come up and ask me, I've been in this space for a while as well. What do you mean when you say agentic? Do you mean you're just pinging the LLM multiple times with different prompts? And I had to explain our definition of agentic, which is where the LLM has the ability, the LLM or whatever AI model you're using has the ability to change the decision tree, to change the outcome of the task, right? And it has the ability to redirect you to maybe the next agent or the next node, depending on how you've described your task. And that could meaningfully impact the outcome of the job that is assigned to the agent. So that definition aligns with what LangGraph defines agents as.
Yeah.
But quite often I've seen that conflated with things like, okay, just have multiple LLMs at some points in the system, and there is information being passed around, but it's not really involved in decision making.
Yeah.
So I've seen that mixed sometimes, so that could be conflated. But I think overall, when we talk about multi-agent, I think those applications will soon, they will not be something significant.
Yeah.
We'll see very strong agentic applications like Blitzy, and I'm sure others in the space, that redefine what it means to be agentic, aligning it to the correct definition and grounding it in that.
Yeah. So far we have 2025. We are going to leverage all of the new software tooling to connect to systems that we otherwise couldn't connect to. We are going to be able to leverage that in a multi-agent system to do some work. And I think I'm curious where we're at on a few of the key S curves to tie all the way back to, like, is AI slowing down? I'm so sick of this hype. So we have the chip layer, right? We have the training of the LLMs and their performance. It's a lot of talk of, like, is 4 better than 3? Is O1 that much better than 4, right? And then we have the inference layer, right? And so talk to me about those 3 buckets and where you think we're at.
Well, I think it is far from slowing down. I think we're only getting started. And you can look at the industry and signals therein to understand that. So Amazon recently invested $8 billion in Anthropic. And the reason they did that is that part of the deal, if you look into that, is that Anthropic will exclusively be using Amazon's Trainium and Inferentia chips.
Yeah.
So Amazon, which has AWS, which is one of the best cloud providers in the market, as mentioned by developers. Once
you're not personally saying that.
I'm not personally saying that because I love Google Cloud.
Yeah.
But Amazon is pretty good. I respect to them. They've perfected the space, and I think I see them realizing that Claude's models. The key part about Claude's models is that The other models, they perform great on benchmarks. Like OpenAI is going to put out these benchmarks and show you how they're crushing it, and they're the best model on the leaderboard. But when you actually put it to the test, it turns out, nope, Sonnet 3.5 V2 still exceeds it in all the practical benchmarks. So you have, on one end, LM-Sys clearly calling out some other model, maybe O1 as the better model, but when you use it practically in the API, it's something completely different. So that's a challenge of the space at the moment. But coming back to AWS and Trainium and Inferentia, so AWS or Amazon isn't claiming that these models are going to go head-to-head or toe-to-toe with NVIDIA or on their best GPUs. But you now have an option that lets you do simpler use cases, maybe not to train O1, but maybe simpler use cases for training smaller models or for fine-tuning models. You can use Amazon's chips, and you have a cheaper option. The key highlight of this announcement, of this release, and of this whole thing is it's much cheaper than NVIDIA. And your only option is no longer NVIDIA if your use case is not as high end. And I think that is a very, very big deal that is underrated because it makes accessible the ability to train specialized models without having to burn millions of dollars in training.
And they're now accessible through AWS, right? They just launched recently Acre.ai, Liquid. Those are all accessible via AWS, which is new, brand new as of 2 days ago. And so they're doubling down on training your own model for a specific purpose with our chips. And then you have distribution.
Yes. So you have you have Bedrock, which is great at distribution, which all of these providers are using. You have Trainium and Inferentia, and that's just Amazon. So Google has their own version of it. Google has their own TPUs for a while now, and that's on the inference space. And inference, so I keep saying this, I'd like to say this on camera. I think you don't need GPUs for inference. I think we're going to see CPUs become more and more predominant for inference going forward. There are a bunch of companies that are working on this particular solution space. There are specialized chipsets focused on solving specific problems. Like, for example, there are ASICs for matrix multiplication. I'm not super bullish on those because I still, coming from NVIDIA, I believe in the generalized chip mindset. But I think inference in particular is not a super complicated problem that you need GPUs for. So we're going to see CPUs definitely solve that problem. It happened with cloud. It's going to happen again with inference. But when it comes to training, I would say that I strongly believe that at the top of the top layer, so 50% of NVIDIA's revenue comes from the top 4 chip makers. So not chip makers, come from the top 4 hyperscalers, right? Four customers, and that's going to remain. Because when they want to push the frontier and you want to train the biggest, most complicated model, that's going to be NVIDIA, hands down. So, and that's going to be the case for the next 5 years or even 10 years. It's impossible to touch NVIDIA, in my opinion, just because they have this strong community of CUDA developers. They have a well-oiled engine that's functioning at its peak, and you cannot dethrone them at that. But are we going to have other options than NVIDIA? Definitely. And are they going to be just as good at everything that's not training the best of the state-of-the-art model? Definitely.
Well, let's talk about how good these chips are supposed to be, right? There's anywhere from 2x to 30x, depending on what insider information you're getting. So what effect do you think that's going to have on GPT-5 or 6?
I think not as much on GPT-5 and 6 because, that's still going to be NVIDIA. And, NVIDIA's chips, Jensen, I think, recently said it's 100x better, the next generation. So if you believe that it is indeed 100x better, it means that OpenAI is going to be able to train GPT-5 to a much higher quality, to a lot more information. I think the last time they trained GPT-4, it was terabytes of information, and it's about low double-digit terabytes, if I'm not mistaken. But if you can get it more information and at the same time specialize in more of that information, right? So it's one thing to train a model to have, let's say billions of parameters and to feed it a lot of data. It's a completely different thing for it to perform well on those specific domains. So, for example, Claude performs really well on coding and on certain other use cases. It definitely is not the state of the art on some other use cases. It's just a matter of how much data was used in different domains, right? So with GPT-5, if NVIDIA's chip is really that good,
Yeah.
it unlocks the ability to specialize in more domains,
Yeah.
right? So you will get these big supermodels that we were talking about earlier that can specialize in multiple domains, and then you now have you get closer to a one size fits not all, but a lot more areas. So it's going to be easier for developers like us, because if I have one model that works better for a lot of the use cases, it reduces the amount of engineering work I have to do to figure out, the best model for the best use case, and it makes us that much more faster to build.
Yeah, and so I think this is a good transition point. The chips, Jensen says, are getting better. Jensen doesn't exaggerate. He's a man of his word. The models are going to get better because of that. We don't really think there's this talk about the scaling laws are slowing down, and there's a natural limit to that. I think there's a lot of engineering work there, to be honest, that needs to be done to make it happen. But I think the teams are going to pull it off. And then we're now at inference, which you talked about, the CPU. But where do you think we're at on the S curve of exploring inference?
I would say, inference. I would say we're very we're juvenile at this point.
Yeah.
It's like it's immature. It's just getting started.
Elementary school.
School.
Yeah.
Because we haven't really scaled up the infrastructure for inference. We are using the current generation technology and trying to scale that up for inference. But now what we're going to get is chips that are specializing for inference, for specific use cases, for the exact operations. We've now generated tons of data by all of the major model providers and hyperscalers that lets you visualize, what are the operations that are being executed in the CPU that you can specialize in or speed up, right? And if you've identified 80% of those operations and you sped those up, you've now solved the problem of inference for probably like 90% to 95% of everyone's use, right? So if you can do that and you can keep scaling that up, you can keep pushing the cost down of AI. So I read this article earlier where someone thought the cost of AI will go down 100x from what we have today, the cost of inference, right? From and in a year from now, right? So that's the kind of effect we're going to see once we have things like CPUs for inference, specialized architectures, learning from data that lets us really push the frontier.
Yeah, makes sense. And there are new innovations like test time training. They're a block from here at MIT. They've just published really interesting research on that, of just how dramatically you're able to push quality. Test time training. So talk to us about what that is and what that means.
I think to break it down, there are a few avenues for models to learn. If I were to quote Jensen, he said, pre-training is like going to college, where you get your degree, you've trained in a broad variety of areas, you can answer questions, you can do stuff. Post-training is specializing. So you went ahead and you got a master's degree, right? There's test time thinking, which is reasoning that we've seen O1 do. That is what Blitzy is doing, right? It's test time thinking. And then there is test time training, which is this new technique that these MIT guys have introduced. And it is very interesting because you have you have the ability to detect that the model is not performing well on specific use cases. You have the ability to give it a few examples that fixed that specific problem, and then the result is that it was able to self-correct itself and get a much better output. So I would put it as a variation of something that is during the test time, like we had test time thinking.
Yeah.
We now have something called test time training. I would say it is still complex and expensive to implement.
Yeah.
Just because of how much compute is involved in detecting and retraining, extending the training of that and implementing it. But I think it is a very cool and definitely potentially a useful solution that you can apply for specific use cases. Like we were thinking, maybe if we detect, I think you mentioned this, if we detect bugs during, let's say, validation, we could potentially apply test time training and improve the performance of the model and prevent issues like that.
I think like it's expensive, but test time training sort of is the last step that you would do before all of the traditional validation that you would do. You could do chain of thought, you could do LLM as a judge, you could use all these different techniques because they're easier and more established to implement. But like once you're at the frontier and the model can't solve the problem, you can essentially like cram information, or like it's like cramming before the test, right? It's like, here's 15 examples of similar errors that this language has had, and then give it a shot to see if it can solve the problem. And if it's able to solve the problem and you weren't able to solve it any other way, then whatever the cost is, it's probably worth it. So
for sure.
It's like, I don't know, I'm just pumped that like all of these techniques are coming out and they're just published in papers. And,
and I think that should be an indicator of whether things are slowing down. We also saw recently that this particular test time training paper was the best scorer of ArcAGI, and it even beat some humans in terms of their performance on ArcAGI. So that should tell you really if the space is slowing down, which the answer is a resounding no. This is just one of the examples. There is a lot of other interesting research that is being put out there. I read these papers and I watch the space on a daily basis. And I can tell you we're only scratching the surface of what we're able to do even with the transform architecture.
Well, that's a good way to cap it off. 2025 is going to be a big one.
Yes.
Can't wait to do it with you.
Yes.